The National Electrical Code (NEC) permits ground fault circuit interrupter (GFCI) protected outdoor receptacles to be connected to one of the receptacle circuits within the building. There isn't a requirement mandating that these outdoor receptacles be placed on their own specific, dedicated circuit. The key is ensuring that the outdoor receptacles are indeed GFCI protected. GFCI protection is essential for outdoor receptacles because of the increased risk of electric shock in damp or wet locations. The GFCI device monitors the current flowing to and from the receptacle. If it detects an imbalance, indicating a potential ground fault where current is leaking to ground, it will quickly trip the circuit and cut off the power. This rapid response is crucial in preventing electrical shock. When connecting outdoor GFCI receptacles to an existing circuit, several factors must be considered to ensure safety and code compliance. Firstly, the existing circuit must have sufficient capacity to handle the additional load of the outdoor receptacles. Overloading a circuit can lead to overheating, trip breakers, and potentially hazardous situations. To determine if the circuit has enough capacity, calculate the total load on the circuit, including all existing devices and the new outdoor receptacles. The NEC provides guidelines for calculating the load of general-purpose receptacle circuits. Typically, a load of 180 volt-amps is used for each receptacle outlet. This value might be higher for specific appliances or equipment connected to the circuit. Secondly, the wiring and overcurrent protection of the existing circuit must be adequate for the increased load. Ensure that the wire gauge is appropriate for the circuit's ampacity. The NEC Table 310.15b16 provides ampacity ratings for different wire sizes and insulation types. The overcurrent protection device, such as a circuit breaker or fuse, must be sized to protect the wiring from overload. It should not be larger than the ampacity of the smallest conductor in the circuit. Thirdly, it's important to verify that the existing circuit is not already heavily loaded. If the circuit is frequently tripping or showing signs of overheating, it's a clear indication that it's already overloaded, and adding more receptacles is not advisable. In such cases, a dedicated circuit for the outdoor receptacles might be necessary. Fourthly, consider the location of the outdoor receptacles and their proximity to wet areas. The NEC specifies requirements for the placement of receptacles near pools, spas, and other water sources. These receptacles must be GFCI protected and located at specific distances from the water. Fifthly, ensure that the outdoor receptacles are weatherproof. The NEC requires that outdoor receptacles be protected by weatherproof enclosures when not in use. These enclosures prevent water and debris from entering the receptacle and causing corrosion or electrical hazards. The type of weatherproof enclosure depends on the location and exposure to the elements. In some cases, a simple bubble cover might be sufficient, while in other cases, a more robust enclosure might be required. Sixthly, proper grounding is essential for all electrical circuits, including those serving outdoor receptacles. Ensure that the circuit is properly grounded according to the NEC requirements. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. Seventhly, it is important to inspect the existing wiring for any signs of damage or deterioration. Old or damaged wiring can pose a safety hazard and should be replaced before connecting new receptacles. Look for signs of cracking, fraying, or corrosion on the insulation. Eighthly, consider using arc fault circuit interrupter (FSI) protection in addition to GFCI protection. FSIs detect arc faults, which are dangerous electrical conditions that can cause fires. While GFCI protection is primarily focused on preventing electrical shock, FSI protection is focused on preventing fires. Some jurisdictions might require FSI protection for certain circuits, including those serving outdoor receptacles. Ninthly, when installing the outdoor receptacles, follow all manufacturers' instructions and local electrical codes. Proper installation is crucial for ensuring the safety and reliability of the electrical system. Use appropriate wiring methods and connectors for outdoor applications. Tenthly, it's always a good idea to consult with a qualified electrician before making any changes to your electrical system. An electrician can assess the existing wiring, determine the appropriate wiring methods, and ensure that the installation complies with all applicable codes and regulations. In summary, while the NEC allows outdoor GFCI receptacles to be connected to existing receptacle circuits within the building, it's crucial to carefully evaluate the circuit's capacity, wiring, and overcurrent protection. Proper grounding, weatherproof enclosures, and GFCI protection are essential for ensuring safety. Consulting with a qualified electrician is recommended to ensure compliance with all applicable codes and regulations. Remember that electrical work can be dangerous, and it's important to take all necessary precautions to prevent electrical shock and fire hazards. Consider the following additional factors when connecting outdoor GFCI receptacles to existing circuits. First, the distance between the service panel and the outdoor receptacles. Longer distances can result in voltage drop, which can affect the performance of electrical equipment. The NEC provides guidelines for calculating voltage drop and recommends using larger conductors to minimize voltage drop over long distances. Second, the type of load that will be connected to the outdoor receptacles. If the receptacles will be used to power heavy loads, such as power tools or appliances, it's important to ensure that the circuit has sufficient capacity to handle the load. The NEC provides guidelines for calculating the load of different types of equipment. Third, the environmental conditions in the area where the outdoor receptacles will be located. If the area is subject to extreme temperatures, humidity, or corrosive elements, it's important to use wiring and enclosures that are rated for those conditions. The NEC provides guidelines for selecting appropriate materials for different environmental conditions. Fourth, the presence of underground wiring or other utilities in the area. Before digging to install outdoor receptacles, it's important to locate any underground wiring or utilities to avoid damaging them. Call your local utility companies or use a one-call service to have them mark the location of underground utilities. Fifth, the potential for vandalism or tampering with the outdoor receptacles. If the receptacles are located in a public area, it's important to use tamper-resistant receptacles and enclosures to prevent unauthorized access. The NEC requires tamper-resistant receptacles in certain locations, such as dwelling units and childcare facilities. Sixth, the future needs of the property. When planning the installation of outdoor receptacles, it's important to consider the potential future needs of the property. For example, if you plan to add a pool or spa in the future, you might want to install additional receptacles in the area to accommodate the electrical requirements of those features. Seventh, the availability of GFCI protection. If the existing circuit does not have GFCI protection, you will need to install a GFCI circuit breaker or a receptacle to provide GFCI protection for the outdoor receptacles. The GFCI device should be installed in an easily accessible location. 8. The proper labeling of the circuit. After installing the outdoor receptacles, it's important to properly label the circuit breaker or fuse that serves the circuit. This will help prevent confusion in the future and make it easier to identify the circuit in case of a problem. 9th, the regular testing of the GFCI protection. GFCI devices should be tested regularly to ensure that they are functioning properly. The manufacturer's instructions will provide information on how to test the GFCI device. 10th, the proper maintenance of the outdoor receptacles. Outdoor receptacles should be inspected regularly for any signs of damage or deterioration. Damaged receptacles should be replaced immediately to prevent electrical hazards. By considering these additional factors, you can ensure that the installation of outdoor GFCI receptacles is safe, reliable, and code compliant. Remember that electrical work can be dangerous, and it's important to take all necessary precautions to prevent electrical shock and fire hazards. Always consult with a qualified electrician if you have any questions or concerns about electrical work. The National Electrical Code (NEC) serves as a cornerstone for electrical safety in the United States. It is a comprehensive set of standards and guidelines designed to protect people and property from electrical hazards. Understanding and adhering to the NEC is crucial for anyone involved in electrical work, from homeowners to electricians to engineers. The NEC is updated every 3 years to reflect the latest advancements in technology and safety practices. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is not a law itself, but it is often adopted by state and local jurisdictions as part of their building codes. This means that compliance with the NEC is legally required in many areas. The NEC is organized into chapters, articles, and sections. Each section provides specific requirements for a particular aspect of electrical work. It is important to consult the relevant sections of the NEC when planning and performing electrical installations. The NEC also includes tables and examples to help clarify the requirements. These tables provide information on conductor ampacity, conduit fill, and other important parameters. The examples illustrate how to apply the NEC requirements in specific situations. The NEC is a complex document, and it can be difficult to understand without proper training. It is recommended to take courses or attend workshops on the NEC to gain a better understanding of its requirements. There are many resources available to help people learn about the NEC, including textbooks, online courses, and seminars. These resources can provide valuable information on the NEC requirements and how to apply them in practice. The NEC is not a substitute for professional judgment. It is important to use common sense and good engineering practices when performing electrical work. If you are unsure about any aspect of an electrical installation, it is best to consult with a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and fire hazards. Always turn off the power before working on any electrical circuit, and use appropriate safety equipment, such as insulated gloves and tools. The NEC is constantly evolving to address new technologies and safety concerns. It is important to stay up to date on the latest changes to the NEC to ensure that your electrical installations are safe and code compliant. There are many ways to stay informed about the NEC, including subscribing to industry publications, attending conferences, and participating in online forums. By staying informed about the NEC, you can help to ensure the safety of yourself and others.